This is the first of two videos for Unit 1, Lesson 8. And by the time you're done watching the two videos, you're going to have experienced equations with no solutions and equations that have all real numbers as solutions. So far, we've been working with equations where when you're done solving them, you get the simplest equation you can, and it says something like x equals 5. So what it tells you is if you used 5 in the original equation, you would have gotten a true equation. So 5 solved the equation. But it also tells you if you used any other number besides 5, you wouldn't have gotten a true equation. So that means that any other number besides 5 didn't solve the equation. So x equals 5, still a valid result. We would say that's our one solution. But now we're going to talk about ones with no solutions and all real numbers as solutions. So I think first we should take a look at the objectives. We're going to understand that some equations will not be made true by any variables. That might be a little bit surprising to you. Maybe not so much, but I think most importantly, we're going to learn how to identify those equations. So how are we going to, in the process of trying to solve an equation, figure out, you know what, this is a failed effort. There's no solutions here to be had. And then we'll understand that some equations can be made true by every single value. And we'll also learn how to identify those equations. So first, a reminder, we could show that x equals 4 was a solution to 2x minus 5 equals 3. And we could also show that x equals 3 is not. And I'm not going to take that equation and solve for x. Instead, what I'm going to do is the real meaning of show, which is to say, well, if I've got the equation and I've got a potential solution for, why don't we put the 4 in and see if it actually does work? So I used a 4 in the place of the x, and now it becomes a question. Is this a true equation? If it is, x equals 4 is a solution. If it's not, x equals 4 is not a solution. So let's see. 2 times 4 is 8. 8 minus 5 is my new expression. And my left-hand side equals 3. My right-hand side equals 3. So yes, it did turn out that 4 made the equation true. I just showed that 4 is a solution. So at this point of your careers, you might think, well, if 4 is a solution, then of course 3 is not. And in this case, you would be right. But I could show that. I would use 3 in the place of x this time, and I would simplify the left-hand side until I saw if it matched the right side, because that's what I mean by those question marks there. And in this case, the left side becomes 6 minus 5, which becomes 1, and no, 1 is not 3. So I guess we just showed that the 3 that I used in the place of x is not a solution to the original equation. I want to show you now that in this case, there's a new equation and there's two numbers that are not solutions. So it's not like every time we set up a situation like this, one's going to work and one's going to not. We'll move through this quickly though. We'll use the equation, and on the left side, I'll be plugging in 2. On the right side, I'll be plugging in 5. And I'll be going through the exact same steps on both sides, where I'll simplify and see if the left side matches the right. Now, because of the more complicated looking equation, I've got to clean up both sides. So I'll follow the order of operations carefully, multiplying the 3 times the 2, and adding the 8 and the 2 together. And on the right-hand side, I'm multiplying the 3 by the 5 and adding the 8 and 5 together. So it's still a question of whether the left equals the right. And as you get further and further down the line, you find out no. In neither case. So I found that there were 2 values here that did not solve the equation. So with our experience, you might be thinking, well, how about we just go ahead and solve 3x plus 5 equals 3 times the quantity 8 plus x, and stop beating around the bush. Let's find the value that makes this thing true. We found 2 that didn't work. Let's see what it feels like to solve it. And the fact of the matter is, that's a great idea. But I want you to know that I wasn't just unlucky. Those 2 values that I chose, they didn't work because not a single value ever is going to work in this equation. So I want you to watch as we go to solve this equation when that sneaking suspicion starts popping up. So let's see, it's not right now. We don't have that kind of insight. But if I start to clean up the left side and clean up the right-hand side and start making them, a little bit easier to manage, you might start getting the sneaking suspicion, wait a second here. So what you're telling me is 3x plus 5 is supposed to equal 24 plus 3x. So in other words, if I have 3x and I add 5 to it on the left side, I'm supposed to get the same result as if I had 3x and instead added 24 on the right side. That seems a little unusual, but we're not going to, there's some strange things that maybe you don't have number sense for. So let's just keep on going. Let's try to remove the variables from one side, like we saw in the last lesson. So this time there's a tie. The left side and the right side both have 3x's. So I will just subtract 3x. I'll do it in a balanced way. I'll know for sure that one side is going to lose the variables, and that's supposed to make me feel better. But when I do that, it continues down this path of like very strange feel. There's no x left to be solved for. My original equation is now equivalent to the equation 5 equals 24, with no x to be found. Well, you and I both know that 5 will never equal 24. But we also know we didn't do anything wrong. We were given an equation. We simplified the right-hand side correctly. We used a balanced inverse operation. We didn't do anything wrong to get to this very strange result. The original equation is equivalent to 5 being equal to 24. In other words, the original equation is flat out wrong. It's flat out false. So 5 will never equal 24 no matter what uses x. You can now make the conclusion, since no value of x makes our latest equation true, none was going to make our original true either. So it turns out that the original equation is one that had no solutions. And the way we discovered that, the way we identify such an equation, is you try to solve it the best you can, and then when the variable disappears and you're left with something that's not true, flat out not true, no x's left in it to even help maybe make it true sometimes, then you go, you know what, the original had no solutions. So that's going to be the end of the first video here, and the second one's going to be similar, and together they're going to do the objectives for the day.